All right, in this hopefully short video, we're going to talk about graphs of logarithmic functions, which have already been hinted at a couple days earlier when we looked at inverse functions and their graphs. All right, so why don't you pause, copy this down. I'm going to add to these two graphs, but copy it down and we'll go from there. All right, so what we have learned is that a logarithmic function with base b, so log base b of x, is the inverse of the exponential function b to the x. So these two functions are inverses of one another. Thus, if I know how to graph b to the x, I should be able to reflect that about the line y equals x to get the graph of log base b of x, its inverse. So here I have the two flavors of graphs of the form b to the x. So here my b is greater than 1. So I start low, hit the y-axis at 1, and then end high. And over here, I have the version where my b value, the base of my exponential function, is between 0 and 1. So that starts high, hits the y-axis at 1, and then goes low and has the positive x-axis as a horizontal asymptote, whereas this one had the negative x-axis as a horizontal asymptote. These two graphs, just spin it about the y-axis and you get the other graph, which isn't too important, but okay. So let's start with 3 to the x. I'm going to now graph log base 3 of x by getting the inverse graph of this one. So I'm going to throw in my line y equals x. And I actually did this in class a few days ago. There's y equals x. Hopefully you can see that. Okay. And I'm going to take this graph and reflect it about the line. All right. So 0, 1 would come down to 1, 0. So that black dot would move to here. This part up here, if I flip it over the red dotted line, it looks something like this in blue-ish, okay? And then this tail, it would flip from the second quadrant over into the fourth quadrant, right? Because opposite the second is the fourth. So that tail, instead of hugging the negative x-axis, it would flip down and hug the negative y-axis. So that tail would flip over to here. And this would be the graph of log base 3 of x. So, and it goes through the point 1, 0. And I would note it has x equals 0 as a vertical asymptote. Okay. Also, and we talked about this before, the domain is the range of 3 to the x, and the range is the domain of 3 to the x, right? Our domains and ranges switch spots when I go from the function to its inverse. So 3 to the x had a horizontal asymptote at y equals 0. Log base 3 of x has a vertical asymptote at x equals, at x equals 0. Okay. All right. So if my base is greater than 1, this is pretty much what my logarithmic function looks like. Hits the x-axis at 1, vertical asymptote, the y-axis is a vertical asymptote, starts low, ends high, doesn't even get graphed over here, not part of its domain. All right, now this one's a bit tougher. All right, I'm probably going to F this one up, but just bear with me. So here's the graph of 1/3 x, same domain and range as before, hits the y-axis at the same spot, 0, 1. So I'm going to throw in my line y equals x. I missed it, but you got the idea. All right, and now I'm going to flip it about the axis. So I'm going to flip this point down to, where's that black pen? Come here. So 0, the point 0, 1 will get flipped to the point 1, 0. This guy in the second quadrant is going to get flipped down into the fourth quadrant. So this bit, I believe, is going to look like, ooh, come on, you artistic ability people, like that. I take that black thing and flip it over. I think I land on my blue thing. I don't think that sucks. It's not bad for me. All right. Now, where my black line crossed the red line, when it's right on the red line, flipping doesn't do anything. Keeps it there. And then this part If I fold it over, it now starts to hug this. So here's the graph of y equals log base 1/3 of x. Okay. All right. Now, x equals 0 is a vertical asymptote. Domain, 0 to infinity for my x values, and my range, -infinity to infinity for my y values. So in both cases, log base 3, log base 1/3, x equals 0 is your vertical asymptote, same domain, same range. If your b is greater than 1, you start low and climb high, hitting 1, 0. If your base is between 0 and 1, you start high, drop low, going through 1, 0. Okay, right. So those are the two base graphs for logarithmic functions you should memorize, right? Log base b when b is greater than 1. Log base b when b is between 0 and 1. Okay. All right. I'm going to do one example where I do a graph transformation now. All right. Okay. So why don't you copy down the problem, and I'm going to show you what you need to put on your page, and then I'll fill stuff in. So pause, copy this problem down. And please note that there's one other graph at the far end of the board. So I need to draw 4 graphs here to do this. Okay. All right. So let me begin. Oh, no, I'm not going to begin. The black marker. Now you'll see the colors of the rainbow. Okay, so please recall that the natural log of x meant it was log base e, where e was this deeply fascinating number, 2.71829 something, 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 okay? All right, but it's greater than 1. So this is log base b, where b is greater than 1. Now, according to the work we just did, we know basically what that graph looks like. It crosses the x-axis at 1. It's got x equals 0 as a vertical asymptote, and it starts low, crosses at x equals 1, and then just sort of heads up high. Oh, that looks atrocious. That looks atrocious, but what can you expect? What can you expect? Okay, so there's the graph of the natural log of x. Great. Now I'm after the graph of the negative natural log of x plus 2 plus 3. And I'm going to take my transformations in the following order. Starting at x, I'm going to deal with adding 2 to x. Then I'm going to deal with that negative sign. And last but not least, I will take care of adding 3 to everything. Okay. All right. So let's shift over now and go from the graph of the natural log of x to the graph of the natural log of x plus 2. So adding 2 means I need to shift left 2 units. Okay. So I need to take this graph, shift it left 2 units. Okay, well, so that means this point at 1, 0, it now needs to shift over to this point right here at -1, 0. And here I had a vertical asymptote at x equals 0. If I shift it left 2 units, I'm going to have a vertical asymptote at x equals 2. Whoops, a daisy. That was at x equals 3. Axel, you're losing it. You're cracking. Right. There's the vertical asymptote at x equals 2. Okay. All right. It's good. And it's important to show that on your graph, so I know that you're not just making crap up. All right. So then the graph starts on the negative end of the vertical asymptote, crosses at the dot, and heads up. So there is the graph of the natural log of x plus 2. All right. Let's take care of the next transformation. All right, well, hitting my y value is the natural log of x plus 2. Now I'm taking that y value and hitting it with a negative sign. So whenever my y's were positive above the x-axis, they're now going to be negative below. And whenever my y's were negative below the x-axis, they're now going to come up and be positive. So this graph transformation, putting a negative sign out there, means I'm going to flip about the x-axis. Okay. Right, so there's a 1, there's a 2, there's a 3. Flipping, so my vertical asymptote remains at x equals 2. I'm sorry, -2. It's -3. That was a -2. Holy cow, wheels are falling off. All right, so the point on the x-axis, it's still going to stay there. If I flip the point on the x-axis, about the x-axis, it doesn't go anywhere, okay? But this tail down here below the x-axis, it flips up. So now I'm coming down from positive infinity. And this part that's above the x-axis, it flips over. And then I'm sort of going down here, okay? All right, and that's point is still at -1, 0. And I still have my vertical asymptote at -2. Okay. All right, last transformation. I've got to go from my previous step to adding 3. So adding 3 takes my previous y value and adds 3 to every y value. So this is going to shift up 3 units. Okay. Now shifting up doesn't transform the vertical asymptote. It just shifts me up the vertical asymptote. So at -1, -2, I still have a vertical asymptote. That point that was at -1, 0, I now need to shift it up to -1, 3. So there I am at -1, 3, -1, 3. And that tail shifts up as well. So it looks like I go up my vertical asymptote there. And then I just drop down from there as I was before. And so that would be my final answer. That is the graph of negative the natural log of x plus 2 plus 3. Right? So you should understand what the basic graph looks like for log base b of x if b is greater than 1. And if b is between 0 and 1. So you should have those memorized. You should be able to put them on a piece of paper right off the bat. And then we'll just work on graph transformations on those basic graphs.